Ever wonder how the Romans built an empire that lasted for centuries? Welcome to ClassBites. Today, we're diving deep into the engineering marvels that made it all possible, their incredible roads and aqueducts. The Roman world was built upon a foundation of unparalleled engineering, a practical genius that transformed landscapes and defined an empire. More than just monuments, their creations were the very systems that enabled its expansion and sustained its existence. From the arteries of transport that bound provinces together, to the great structures that projected imperial power, Roman ingenuity was a force of nature in itself, leaving behind a legacy etched in stone and concrete. The empire's lifeblood flowed through two critical networks, its roads and its aqueducts. The Appian Way, the Queen of Roads, was born from strategic necessity during the Samnite Wars. It was not merely a path, but a sophisticated piece of infrastructure designed for permanence. Engineers would excavate a trench down to bedrock, sometimes 3 feet deep, before beginning the meticulous process of layering. A base of mortar was followed by a foot-thick course of large stones bound by cement, then a layer of rammed concrete, and finally a compacted bed of gravel and sand. The surface, or summa crusta, was a mosaic of expertly fitted polygonal slabs of hard volcanic rock, cambered to shed rainwater into drainage ditches that ran alongside. This multi-layered design ensured durability against heavy military traffic and the elements. At its zenith, this network spanned over 400,000 kilometers, with more than 80,000 kilometers paved in stone, a testament to the Roman preference for engineering through obstacles rather than circumventing them. Just as roads carried legions and commerce, aqueducts carried the essential resource of water, enabling cities to swell to unprecedented sizes. Rome itself was eventually supplied by 11 major aqueducts, delivering over 1 million cubic meters of water daily. The first of these, the Aqua Appia, was constructed during the same period of conflict as its namesake road, and was built almost entirely underground as a defensive measure. The engineering behind these conduits was a marvel of precision. Surveyors used instruments like the Corobates, a long wooden level, and the Groma for laying right angles, to establish a gentle, continuous gradient over vast distances. While the iconic image of the aqueduct is a towering bridge of arches crossing a valley, the majority of their length, often more than 80 or 90 kilometers, consisted of subterranean channels. These conduits, large enough for a worker to enter for maintenance, were lined with opus signinum, a waterproof mortar made from lime and crushed terracotta that possessed the remarkable ability to set in the presence of water, ensuring the integrity of the channel. In the heart of the city, this engineering prowess was displayed not for utility but for spectacle and political statement. The Flavian Amphitheater, known to history as the Coliseum, was a monument born from a populist gesture. Emperor Vespasian erected it on the site of the artificial lake of Nero's opulent private palace, symbolically returning the land to the Roman people. Funded by the spoils of war, it was the largest amphitheater ever built. Unlike earlier Greek theaters nestled into hillsides, the Coliseum was a freestanding elliptical structure. Its immense weight was supported by a brilliant system of radial and concentric walls, employing arches and vaults to distribute the load, and create corridors, the vomitoria, which allowed its estimated capacity of 50 to 80,000 spectators to fill and empty the venue with astonishing speed. The facade was a masterclass in classical design, rising in 3 tiers of arcades framed by columns of the Tuscan, Ionic, and Corinthian orders. The structure was built primarily from over 100,000 cubic meters of travertine limestone, held together not by mortar but by 300 tons of iron clamps. Beneath the arena floor lay the Hypogeum, a complex 2-level subterranean world of tunnels and chambers. Here, a sophisticated system of elevators and hoists, powered by dozens of large capstans, delivered combatants, scenery, and caged animals to the surface through trapdoors, creating dramatic and surprising spectacles for the crowds above. To shield spectators from the sun, sailors from the Roman fleet were tasked with operating the velarium, a colossal retractable awning that stretched over the seating. If the Coliseum was a monument to public spectacle, the Pantheon was a temple to architectural perfection and the divine. Rebuilt under the Emperor Hadrian, it represented a synthesis of Greek tradition and Roman innovation. A visitor first passes through a classical portico supported by 16 monolithic granite columns, each weighing 60 tons, that were quarried in Egypt and transported across the Mediterranean. This traditional entrance gives way to a breathtaking surprise, a vast circular interior crowned by a magnificent coffered dome. For centuries, it remained the largest unreinforced concrete dome in the world. Its genius lies in its construction. The Roman concrete, or opus signinum, was a revolutionary material, a mix of lime mortar and aggregate. For the Pantheon's dome, engineers varied the aggregate to reduce the structure's weight as it rose. Heavy travertine was used at the base, transitioning to terracotta tiles in the middle sections, and finally to light porous tufa and pumice near the apex. The dome's immense stress is channeled down through its 21-foot thick walls into massive piers, with relieving arches hidden within the structure to direct the forces. The recessed panels, or coffers, were not merely decorative, they further reduced the dome's mass without compromising its strength. At its very top is the oculus, a 27-foot wide opening to the sky, the sole source of light, connecting the earthly space with the heavens. The concrete itself possessed a secret to its longevity. The use of volcanic ash known as Pozzolana created a hydraulic cement of incredible durability. And recent analysis has revealed that lime clasts within the mixture acted as a self-healing agent, dissolving and recrystallizing to fill cracks over time. The impact of these achievements echo through millennia. The layered construction of Roman roads is a principle still used in modern highways. The Coliseum's elliptical design, tiered seating, and system for crowd control became the blueprint for virtually every modern sports stadium. The mastery of the arch and the dome, perfected in the Pantheon, was rediscovered during the Renaissance and became a cornerstone of Western architecture, influencing everything from great cathedrals to national capitals. The structures the Romans built were more than stone and mortar. They were enduring systems that shaped the physical and cultural landscape of the world, a testament to an engineering vision that remains foundational to our own. Thanks for watching. Please like, subscribe, and comment with your thoughts or what you'd like to see next.